Hi guys, in this video we're going to be talking about the types of bonds, and we're going to be using the periodic table to think about whether what kind of bonds are involved in a particular compound. The first type we're going to talk about is metallic, then we're going to talk about ionic, then we're going to talk about covalent, and then there's two kinds of covalent compounds and then something special that happens regarding ionic and covalent compounds. And so let's start with metallic. So here's our periodic table. In order to understand this, we need to know where the metals and the nonmetals are. And you might remember that these guys here along the edge are metalloids. But remember, metalloids are nonmetals that act like metals. So they're going to be lumped with our nonmetals here. And remember that hydrogen is one of those nonmetals as well. And then everything else in the periodic table is a metal. Okay, when we're talking about a metallic bond, we're talking about a metal and another metal that have been combined. This kind of compound is called an alloy frequently. You may have heard the term alloy. An alloy is when two metals are combined. Brass and steel are a couple of examples of alloys. In a metallic compound, each nucleus of the metal attracts all the other electrons. And so what you end up with is a really tight network. So let's say this is our nucleus, and here's another nucleus, and here's another nucleus, and they've all got their electrons. And this guy is holding on to that one, and this one, and that one, and this guy's holding on to that one, and this one, and that one, and this guy's holding on to that one, and that one, and that one. And so you can see that it's all really tightly connected. Those electrons there are all, they're also kind of free to move about too. So, but these tend to make the metals stronger. You can make a soft metal a little bit easier to work with and use by combining it in an alloy. In an ionic compound, we have a metal and a non-metal. And in this kind of compound, what you have is your metal gives up its electrons to, and we're talking about valence electrons here, valence electrons to a non-metal. And those guys both become ions. In fact, they become oppositely charged ions. So, for example, sodium becomes a +1 and chlorine becomes a -1. And those plus and minus attract each other, and so that's what holds them together. These guys get held together in a kind of a network too, where you've got your +1 and your -1, and they're all kind of attracted to each other, and they call this a formula unit because that's the minimum number that you need in order to have everybody happy, which we'll talk about in another video. In a covalent compound, it takes two nonmetals, which is the only other combination that we could have up here, nonmetal and nonmetal. And in this one, what happens is the nonmetals share those valence electrons. Okay, now the valence electrons, they come in pairs and not pairs, which if you've talked about electron dot structures, you've already seen the pairs and the non-pairs, but it's only the unpaired electrons that get shared. So if we take fluorine, fluorine has 7 valence electrons like this, and another fluorine has another 7 valence electrons like this. And both of them pretend that they have this little pair right here. So we call that the bond or the bonding pair. And so that's where they are. And then there's some more that we can talk about with covalent compounds. Sometimes they share more than one pair of electrons, which is a little weird. But with this sharing of electrons, there's two possibilities here. We've got polar covalent bonds and nonpolar covalent bonds. And you're going to get these mixed up because of this little non right here. So I'll see if I can't help you with that. With a polar covalent bond, this sharing right here happens between, let's use kindergartners, this sharing between kindergartner atoms, one of the kindergartners is far more greedy than the other one, and so we have unequal sharing, okay? Unequal sharing for the polar covalent compound. And the way that you would figure out if something was polar covalent or not is on the back of your periodic table. There's this lovely chart down here of electronegativities. And if the difference, the electronegativity difference is, hang on, greater, is it greater than? Yeah, greater than, hang on, we'll use a symbol. If the electronegativity difference is greater than or equal to 0.5, Okay, so if you take two of these numbers, let's take this one, silicone, and this one, iodine, we got 1.8 and 2.5. The difference there is 0.7. So those would be polar covalent. That means that the iodine is more greedy than the silicone, so it holds on to those tighter, so we get unequal sharing. Okay, so that would be like this. Here we got this hand with the pencil. This one's like, hey, my pencil. You hold on to that very end. So that's unequal sharing of the pencil right there. Okay, so that's polar covalent. Nonpolar covalent is equal sharing. But if you want to, cope with this non, you might think of it as not unequal. Okay. Polar is unequal, not polar is not unequal. Okay, if you can remember that, I think that might help you keep those straight. And the same idea here is the electronegativity, which is a really long word to write out, difference is less than 0.5. So if those numbers are close, like P and S, phosphorus and sulfur here, those guys, they're going to have more equal sharing. So instead of iodine and silicone, we have some equal sharing of the pencil. So they're both holding onto it equally. Okay, so that's polar covalent compounds. Now, the last thing we got to talk about is, and I'm drawing a little line right here, is polyatomic ions. Okay, so sometimes what happens is you end up with a polar, you end up with a covalent compound that has a charge. And that happens because maybe they don't have enough electrons to have everybody sharing, and so they lose one or they gain one, and they end up having a charge. So we have a covalent compound that has a charge. Now, the nice thing for you guys is you don't have to be able to come up with these on your own. There is this lovely list on the back of your periodic table. See, common polyatomic ions by charge. And you'll have access to this on all of your quizzes and homework and tests and whatnot. And it has the formulas and the charge on each of these guys. So you just have to be able to find their name and know when you're looking at a polyatomic ion. So when you see a polyatomic ion, what you're going to see is you're going to see a metal and two or more nonmetals. Okay, in order for this kind of compound to work, these two nonmetals must be a covalent compound, and then these two particle pieces, the metal and the covalently bonded polyatomic ion, those are going to be having an ionic compound. So when you see something like this, it's usually going to, sometimes we say that it has both ionic and covalent compound bonds in it, and so that's what we're talking about with the polyatomic ions. So that's pretty much it there. Those are our different types of bonds. Again, recognizing them based on what's in them is the easiest way to go at this point in time, and at some point in time you'll also look at the properties in them. Thanks for watching. Let me know if you have any questions.